Okay. Where are we? In, I don't know, where let's say that we are in Hartford, Connecticut. Wherever your house or the building that you are working with is. And now, this is what we need to do now. So first, you remember that we have used this. This is the azimuth. So this is the orientation of our PV panels. And this is the tilt. So this is the angle. For example, if you are working with the Venturi house, because we have two kind of houses here. Okay, so we have this Trubeck house. This Trubeck house, if we have it's not working. Okay, if we have this house, this is the site plan. So this is north. This is south. So this roof is, let's say, northeast or southwest oriented. Okay, so this is the northeast orientation, and this is the southwest orientation. So let's do this now. Okay, so we have this house, so we can place PV panels here and there. And what is this angle? So this is the first thing we need to find out now. So we need to find the angle of this roof. Okay, so I think this angle is very close to 45. Okay, if it's not 45, it has to be close to this. Okay, so let's say that we have 45 degrees. This is the southwest orientation. And this is the northeast. Okay, so we have these two orientations, and the angle is 45. What is the roof area? Is it here somewhere? This is the roof. Okay, we don't have the roof area, so I'll make it up. So let's say that the area is 1,000 square feet. In the northeast, the area I think is the same. It's, let's say, 1,000 square feet. Okay. So now this is our project, and this is the area that we have available. Now the question is, how much area of PV panels do we need? And this is the area that I have available, at least in my footprint. It's good having this site or this site plan, because if we need more PV area, okay, so I can use part of my site. Of course, I cannot place PV panels underneath the trees because it doesn't make any sense. So if I have an open area exposed to the sun, then I can place PV panels there. It will affect So it has an effect because I can see that. So if we don't like them, I think it's better if we start using the roof area first because it doesn't affect the rest of the site plan. So let's work with our building footprint, and then if we need more, we'll see what we can do. Okay, so this is the real problem that you have if you're working with this house. You have this area, you have this orientation, and you have this angle. Okay, so how can we work with that in the PV Watt? Okay, so for the angle, it's the tilt. So the angle is 45. What about the azimuth? Let's say that we are working first with one of the orientation. Let's work with the southwest orientation. So if I click here, southwest, the angle is 225. So the angle here would be 225. And now this is the system size. So this is related to the amount of panels that we are working with. So we know that the area is 1,000 square feet. Okay, and now we need to know how many panels we can place in this 1,000 square feet. Okay, so let's work with the catalog. We need a catalog. So I have found on the internet that wonderful Chinese company PV panel catalog from 2015. Well, I don't think there's a difference now. They are Chinese, I don't know, but with this logo, I bet they are Chinese. And they have a catalog. This is polycrystalline for sure. It's or crystalline or polycrystalline, so it's not thin film technology. So we can make sure that we have the best efficiency here. And the only thing is that, well, look at this. This is the information that we need. So I'll copy this. And I'll place this in my slide. Okay, so this is my PV panel. First, dimensions. Everything related to PV panels or to photovoltaic technology, I think it's in millimeters, it's in international units. Okay, so what is we need to know the dimension of one panel because we have a limited area. We have 1,000 square feet of roof. So how many panels can we place there? Okay, so this is 1.64 times 0.992. These are those dimensions. As you can see, we have 992 millimeters. 992 millimeters, it's 0.992 meters, and 1,640 millimeters is 1.64 meters. Okay, so I need to calculate this area. This is the area of a panel. The area of a panel is 1.64 times 0.992. It's 1.63 square meters. We are working with square feet, so we need to convert square meters to square feet. Okay, so 1 square meter, how much was it? It's 1.63. 1.63. It's 17.5 square feet. Square feet. Okay, so this is the area of one panel. Now, how many panels we can place in our building? If we have 1,000 square feet divided by the area of one panel, it is 17.5 square feet. So the number of panels, it's 1,000 divided by 17.5. It's 57.1. Let's say around 55 panels. Okay, so first we need to select the panel that we have in our catalog, this one. Okay, if you find a catalog with inches, I don't know, all the catalogs I have found, especially if they come from China, which are the cheapest ones, they are in millimeters or meters. Anyway, we can convert it easily. So we need to calculate the area of the panel in square feet. And then how many panels do we need? This is the area that we have available. In this case is 1,000 because we are working only with this part of the roof. Then we can try the northeast as well. But now we're using the southwest. So if we have 1,000 square feet divided by the area of one panel, so the total it's 55 panels. Now, what is the power of the PV array? Power of 55 panels. So we need to know the power of one panel. And this is what we have here. Okay, so if you look at this brochure, this is the maximum power, 185. But here we have a maximum power, 250. What does it mean? Okay, so that's the difference between the NOCT and STC. What is this? This is the standard test conditions, and this is the, what is this? What is NOCT versus STC? Okay. What's the difference between STC in photovoltaic module specifications? Okay, STC stands for Standard Test Conditions, and NOCT, it's the normal operating cell temperature. What's the difference between, well, so here people are explaining that. We have the standard test conditions. So the standard test conditions for the PV panel means that we have the best possible conditions to operate the PV panel. So those are conditions that usually don't happen because we need a certain solar irradiance, the maximum solar irradiance that we can have on Earth. Then the right temperature for the PV cell, which is around 72 Fahrenheit. And then what is the third? Yeah, so we need this irradiance, which is the maximum irradiance that we can have on Earth. Then the surface temperature is 25 Celsius, around 72 or 73 Fahrenheit. And then a light spectrum that closely simulates sunlight. Okay. So we have three conditions for this standard. So those are the best possible conditions on the Earth's surface. Does it happen? Maybe it happens 1 second per year. We have these best possible conditions. So if we select this maximum power under STC conditions, this is very unlikely. Okay, so we are deceiving our client and we are deceiving ourselves because this is not true. So that's why I would rather use the NOCT conditions. Why? Because these conditions, the irradiance is lower, the temperature is different, and we have wind speed. Okay, so we have to consider that there might be cloudy days, there might be wind, and if the temperature of the cell is above 70 or 72 Fahrenheit, it reduces its energy production. Okay, so the NOCT conditions are more likely to happen. Yeah, we can say, okay, let's make the calculations with the best conditions ever, but that will happen only a couple of seconds per year, so it's not feasible. Anyway, you will find that people are using these STC conditions to run these calculations. Well, we have both. If we only have this information, okay, we can go ahead with this. But since in this outstanding Chinese company, we have both conditions, we have the best conditions and the NOCT, the normal operating cell temperature. So let's use this. So each panel is 180 watts, 185. Okay, so let's do this. One panel is 185 watts, and we can specify this is the NOCT conditions. Okay, so if we are doing this, it looks professional because he's using this kind of conditions. He has not made up this figure, or the architect has not used the standard. No, so he has used this one. Perfect. Okay, and then how many power? So what is the power of 55 panels? So we have 55 times 185. That is 10,175 watts. And this is 10.2, let's say, kilowatts. Okay, so you see what we have done. We have selected the panel. We have this dimension of the panel. We have the roof, our roof area. We divide the roof area by the area of a panel. And then we have the amount of the number of panels that we can place on our roof. Second, we need to go work with the power. So we have to look at this normal operating cell temperature. So this is 185. We have 55 panels, so 55 times this. So this is the power that we can produce. And this is in kilowatts because we need, this is watts, so we need to divide by 1,000. So this is 10.2 kilowatts. Okay, so this is the value, this 10.2 is the value that we have to use in this PV watt system info, because this is the system size in kilowatts, you see? So by default, we have 4, but in our house, this is 10.2. Then we have the module type. If we click here, we have the standard, we have the premium, and we have the thin film. So we can use thin film. I don't think it makes any sense. And we have the standard, we have the premium. I don't know, since they are Chinese panels, so let's use the standard. And then the array type, it can be fixed, or it can be, we can use a tracking. With fix, we have open rack and we have a roof mount. In this case, we have a roof. What is an open rack PV array? This is an open rack, okay? So we are not placing the panels on the roof. So we have this structure, and then we place the panels there. So this is an open rack. And what is a tracking? Okay, a tracking PV array, it's something too complicated. We don't have this in houses. Okay, so this is, as you see, there's an engine here. So it rotates to make sure that the PV panel is always perpendicular to the sun. Okay, so it moves the PV array. It's very expensive. Is it worth doing this? I don't know. I don't know any single family or any house that has this. It's too complicated. Okay, because it rotates, it changes the tilt, and then it changes the azimuth so that the panel is always following the sun path. Yeah, it's cool. It's more efficient, but it's extremely expensive. So nobody is doing this. Okay, well, nobody. I mean, in single family houses, they are not doing this kind of thing. Well, on our PV watts, let's say this is fixed roof mount. It can be fixed open rack or roof mount, depends on you. And then what is this? This is the system losses. Yeah, we have system losses because we have to convert a direct current into alternating current, and we have to, yeah, from the PV panel to the device, we have losses. So it's common that we have a 14% of system losses. Okay, that's fine. Okay, so here we can set type if we are, I don't know, premium. This is something that the company should provide us with a certificate. Okay, no, this is a premium, but believe me, there's no, I would rather use the Chinese panels if they are cheaper than a certificate that this is a premium technology because, well, it's my opinion. Probably if you talk to experts in PV panels, they might think something different. Anyway. So the tilt is the angle of the roof, and the azimuth is the orientation of the house. And that's it. And now we can go. There you go. And this is the value that we need now. And we have to compare this value to our demand, which is 780, because this is monthly. Okay, so we have to calculate the monthly energy demand, and then we have to compare this. It's quite good, I think, because the demand is 780, so we are above the demand throughout the year. Maybe in December we don't meet the demand, but in April, May, or in summer, we have more. Okay, so it's quite good. So with this area, we can meet the requirements of the appliances without heating and cooling. Okay, if we need to take into account heating and cooling, things will be different. But do you understand that in this house, with this angle, with this area, I made it up, so I don't know if it's 1,000 or 2,000 or 115, I don't know. But with this area, this angle, the south-west orientation, we can meet the energy, the electricity demand, the monthly electricity demand for all the devices of the house. What if, okay, so this is the south-west, but I want to place it in the southeast. So we have the same DC system because the roof areas are the same. The angle is the same. The only thing that changes is the azimuth. So what is the northeast? Is 45. Okay, so this is, I type here 45. So will it be different? Let's find out. It is different. Okay, so look at this. This is 200, it's 300, this is 160. So by placing the same amount of PV panels with the same angle, but in different orientation, here the production, it's much lower. Okay, so that's why it's worth doing this beforehand, before moving on in our design process, because you can see how the orientation matters a lot. Okay, so in this case, if I can make the most of the southwest orientation, it's better than the northeast orientation. So do not place, if you have a southwest roof, make the most of that roof. Do not place PV panels on the northeast, because it's less efficient.
What do we do if our roof is flat?
Yeah, what do we do if the roof is flat? That's a good question. So we can, we have the other house here, the Wolfstone. The Wolfson house. Okay, this is a flat roof house. And do we have the roof area here? Roof.
It's 1,172.
1,100, something like that. Okay. Okay, so we can go ahead with this. Okay, there you go. The area. Well, first, it's a flat roof. The area, it's around 1,170 something. Okay, something like that. 1,170 square feet. So now we can try a flat PV array, because the information about the panels are the same, so we can use exactly the same. We can use the same slide for the panels. There you go. The area of the panel is the same. How many panels? Well, since we have now 1,070, maybe we can have more panels. Let's say 170 divided by 17.5. This is, it's around 67 panels. Okay, we have more area, so we can have more panels. So what's the power of 67 panels? If one panel is 185, so it doesn't change. So this is 67. And now the watts are 67 times 185. It's 12,395. So this is around 12.3 kilowatts. Okay. So now let's do it. Let's go to the PV watts. We have to come here. Now the tilt, if it's a flat roof, it's 0. The azimuth doesn't change because if we have a flat surface, we don't have orientation. So usually if we have a flat surface, we select the south, it's 180. Yeah, 180. Okay, so if it's flat, we can select 180. The same Chinese module, the same. Oh, now it's not roof mount. Well, it can be roof mount. If it's flat, it can be roof mount, okay? And the system losses are the same. So I have changed the array. Now it has to be 12.3, 12.3, 0, flat roof, azimuth 180. If it's flat, this should be 180. Then we go to the PV watts. And this is it. Well, it's not bad. It's above the most of the, except December and January, the rest of the year, it's above the demand. It's above 780. Okay, that's good. But what if, do we want this, or is there something, is this the most efficient layout for our roof? If we have a flat roof, we have to think about this because we can have an open rack. Open rack PV array on roofs. Okay, this is a roof mounted, so we just place the PV array on the roof. But if it's flat, we can do this. Okay, so we can have an open rack here on the flat roof. The problem with this is that we have to reduce the roof area because we have an angle. Okay, so that would be an open rack on a flat roof. Okay, or something like this. What's the problem? So this is geometry now. This is my panel, and here I have dimensions of the panel. So it's 1.6 divided by. So imagine that we have this. What is the best angle? The angle matters as well. So the best angle is the angle is the latitude. Okay, so if this is the flat roof, okay, this is the flat roof, then the angle here it can be 40, I think would be a good angle. Let's say 40 to 45, something like that. Okay. But what about the distance? The problem is that now we can't place. Okay, so we can't place another PV panel here. Why? Because the sunlight is coming like this. Okay, so this one is casting shadow on that panel. So we need to separate the panels so that we don't have shade here. Okay, this can be a shaded area. Well, it's very. So this can be a shaded area, and this panel is not working if it's in shade. So if we have a flat roof with a flat, let's copy this, and this. Okay, if it's a flat roof with flat PV panels, then I can place those PV panels like this. We always need a distance, minimum distance between one panel and another one. Okay, but it can be something like that. If it's a flat roof and we need an open rack option, probably we will gain efficiency, but we will lose PV panels. So depending on the angle, how many rows do we have here? Well, this is something that we have to do with geometry. Well, and first we need the orientation. So if we look at the house, so this is the south and this is the north. So we need rows in this orientation. Okay, so how many rows can we have here? It depends. We need to find out. Okay, so now we need to make, so the first option is the flat roof. Okay, so we have done this. With this flat roof, we can copy and paste our production. Here. Okay, and what about this? Okay, so we need to know how many panels do we need. Now this is not an option. We cannot divide the area by the area of the PV panels, but I'm sure that we will have fewer panels. So let's say that we have 40 panels. What is the power of 40 panels? Let's say, so this is 40 times 185. So let's do this. 40 times 185. And this is 7,400 watts. In kilowatts, it's 7.4. Okay, so now let's do this. The PV array is 7.4. The angle is 40. And the azimuth, it's south. Okay, so we have to go back to the system info. So now this is 7.4. Standard, whatever. The angle is 40. And now this has to be south oriented. So there is no point of having, if we have a flat roof and we have an open rack, the orientation has to be always south because it's the most efficient one. Okay, so let's look at the production. And this is the final outcome. Okay, Nicolas, what do you think? This one or that one?
I'm sorry, could you repeat that?
Yep. So we have two options. We have the flat roof, and this is the yield of a flat roof with more panels. Okay. And this is the yield of a flat roof with an open rack and fewer panels. So now I'm comparing both results. This one and that one. And here I have the summary. So this is a flat roof What was the amount of the number of panels with the first option? I don't remember. I think it was 65 panels, something like that. And this is the area with 40 panels. With the open rack. Okay, so what do you think?
Wouldn't the open rack be more efficient?
More efficient. What do you mean with efficiency?
I'm sorry, I'm still a little confused.
Yeah, so it's I want you to be confused because it's not an easy question or it's not an easy answer. The question is easy, but the answer is complicated. The efficiency, I mean, the panel is the same. So if we're talking about the panel efficiency, it's the same because we are using the same panel for this option and for the second option. Okay, so efficiency, it's not. We have to talk about the production. So what option produces more electricity throughout the year?
The flat roof.
This one. So this one is 13,000 and this one is 9,000. Okay. Which one costs more?
The flat array.
Yeah, because we have 65 panels and here we only have 40 panels. What is, okay, how much does a PV panel cost? You don't know that? Well, that depends. So let's go to my favorite website, Alibaba. And let's search. I'm searching for PV panels. Okay, so here one piece, it's around 55 for $46 to $55. I prefer this one because we can have the price per pieces, or we can have the price per watts. Okay, so this is more realistic because we are, so look at this, it's like 22 cents. This is 21 cents per watt. Okay, so the price is around 20 cents per watt. So what is the thing here? What is the so for this option we have 7,400 watts, and the flat roof, it was, I don't remember that numbers, so I have to do it again. So it was 1,170 divided by the area of one panel was 17, I think. Yeah, 17.5. So 1,170 divided by 17.5. Okay, so it was 67 panels. And now the power. It was 67 panels times 185 watts per panel. So that was 67 times 185. This is 12. Okay, it was 12,400 watts. Okay, so this array produces 1200, 4000, and 12,000, sorry, in 400 watts, and this one produces 7,400 watts. So now the price or the cost, 1200 and 400, 12,400 watts times, what was the price? It was, let's say, 0.2, let's say 20 cents. Time $0.2, 20 cents. So the price of this array is 12,000 times 2. Okay, it's 2,480 what? Dollars. Everybody understands dollars. And what is the price of this PV array? So the cost is 7,400 times 0.2 dollars. Well, 7,400 times 0.2. Okay, it's 1,480. Okay, Nicholas, do you have more arguments now? So what would you decide?
I would probably choose the less expensive one.
Well, probably our client will go for the less expensive one. Why? Well, look at this. We are very close to meet the energy requirements. So remember that our demand was 780. Okay, and except in December or November, we are above 700 every single month. So here we have more. Okay, so that's the thing, because we have an excess here in May, June, July. We can sell, if we are consuming only 700, we can sell this energy, and then there is an agreement. So we need more money upfront, but probably we can, if I reach to an agreement with the electric company, maybe they can buy my excess of energy that I'm producing in summer. Okay, but this is now it's not about energy efficiency. It's not about saving the world. We have already saved the world. Okay, so with these two options, we are close to a zero energy building. But now what do? We need to pay more money upfront, and then maybe we can make some money by selling this excess of energy, or we want to pay less upfront, and well, I have just what I need to provide my building with electricity. This is not architecture. This is not building physics or building science. This is about money. Okay? And money matters for sure, because I don't know, but it depends. So first, do I have $2,500? No, I don't. I only have 1,500. Okay, so this is my option because I don't have enough money to do this. But do you understand that here we have options? Okay, so we had the first option. We had this option with more panels, but using flat panels, the efficiency is not as much as using the right angle. By using the right angle in this open rack, we reduce the area of panels. If we reduce the area of panels, I reduce the money that I have to pay up front, but I reduce the energy production, because this is more energy production than this, because here I have more panels. Okay, so this is it. Anyway, if you are working with this Wolfson house, This is the solution to the problem. Okay, so you have different options. Now you have to let me know what option you want to use for your house.